Hi, and welcome to Software Design and Development, Implementation, Lesson 4, Translation and Compilation. Here are the dot points covered. If you'd like to pause the video and have a read of them, you can. Really important for this topic, take notes. There is a massive amount of content for this video. You need to be taking notes as you go through. So we have these two processes of translating source code into machine code. We have compilation and interpretation. Compilation is when you take all of the code and you translate it in one hit and you store the result as an executable file. So it's a file to be run later. The really important thing that you need to take from this is that the program will run really fast once this happens. There's no other process in the background with the code, it's just running by itself. Okay, negatives would include some runtime errors or issues with translation that aren't picked up until the process is finished. So the computer will run through all the processing and some errors may get through and they won't be found until you actually run the code. With interpretation, the programming language will actually run translate each line by line and then run it. So it'll translate line 1, then run line 1, then translate line 2, run line 2, and so on. The positives include the ability to find the errors that compilation doesn't find because it'll run it line by line, and it will give you the opportunity to fix and edit them if you need to. Okay. The negatives, however, is that there's a massive reduced speed of execution because it's got all the translation process happening in the background, and then it runs, and then translates again and runs. So it can be quite a slow process. There are 3 steps in the translation process. The first is lexical analysis. So basically, the source code is read one character at a time, and the analyzer will look at the syntax or the rules of the programming language and determine what sets of characters will make up language elements. And once they're found, they are assigned a token. Any documentation that's in the code, such as spaces, indentation, apart from Python, where the indentation is actually part of the code, and comments from the programmer, they're all removed because they're not needed for the translation process. There's 2 types of tokens. There's the ones that are created for elements which are actually in the programming language, such as constants, operators, and or nots, while and whiles, for, next, if, so on. There's also tokens representing the programmer content, such as identifiers, so things like variable names, subprogram names, etc. Okay, and all these tokens are stored in a token dictionary or a symbol table, along with the other relevant information of the token, so things like variable types, memory locations, and so on. The next step is the syntactic analyzer, and what this does, it takes the tokens from the lexical analyzer, and it arranges them in an order that allows the translator to understand the logic of the problem. Okay, we visualize it through a pass-through. The computer doesn't do this. Does this without graphics. So the translator needs to pass the code in a way there is only one meaning of each line of code. If it can't do this, it determines there is an error. And a really good example comes from the Heinemann text. So there's a sentence, the boy hit the girl with the ball. This would pass an error as there are 2 meanings. The boy assaulted or hit a girl holding a ball. So the boy hit the girl with the ball. So the girl holding the ball. The other meaning is the boy threw a ball at a girl, hitting her. So the boy hit the girl with the ball. And so the example of the 2 pass trees is shown here. So we can see there's 2 different pass trees because there's 2 different meanings. Each word in the sentence can have a different meaning based on what you put emphasis on. Okay? In this case, the sentence isn't clear. We need more language elements, and in this case, in English, we need a comma to determine what meaning exactly we're looking for in the sentence. Okay? If we have that, if the sentence is specifically clear, then we don't have an error, and the computer will execute the line of code the exact same way each time. The next step, according to the Heinemann text, is semantic analysis, and it's not covered by the syllabus, so I'm not covering it here. If you want, you can go to page 157 and learn more. The next step, or the last step, is cogeneration. The translator will run through the pass tree, looking at the tokens, and when it has the right combination for a specific command, it will change them into a command in machine code. These are then saved by the computer when the code is executed. The computer can only ever run machine code, really important. It cannot run any other code. So if you want to run your program, whether it's in Python, Visual Basic, C++, Scratch, whatever, it needs to be translated into machine code before it can run. We also have this linker, and so oftentimes in programming languages or the operating system, there's a whole section of standard code to enable the program to access elements in the operating system or routines to access hardware or things like that. When these are referenced, the linker will make a link to a link in machine code to the correct function, as if you have actually written that in your program. So when you access certain elements in your programming language that reference those sorts of things, so maybe it might be a file operation or so on, or print, if you're printing to a printer, the linker will link to the right section of code, so you don't need to worry about writing it for specific hardware. Now, I've only covered the main points. There's heaps more information in the text. If you want, you can look at it and read it. Okay, I'd recommend a very brief run through at least. But most of the stuff in there isn't necessarily specifically needed for the syllabus, but it's probably good stuff to know, and it could get you a few extra marks in the exam if you do know it.